Hello everyone, welcome back to JDCodebase. Today we are solving two very important array problems from the LeetCode. First one is the single number, LeetCode 136. Second one is the contains duplicate, LeetCode number 217. Now, but we are not just solving them, we will solve them in the three levels of thinking. First approach that naturally comes to the mind. Second one, optimize it by using the XOR trick for the big open and means improve the space complexity. Because in interviews, what matter is not just the answer. It is how your thinking evolves. First, we will build the logic step by step. Then we will improve it like a pro. So let's start. So first problem is the 136 single number. In this, given a known empty array of integer nums and every element appears twice except for one. Find that single one array or the element. You must implement a solution with a linear runtime complexity and use only constant extra space. So I have in this problem, I have a nums array. In the function, I get a nums array like here 2, 2, 1, 4, 1, 2, 1, 2, and every element appears two times in this except for one. Like here 1 is the one time, here 4 is the one time, and I have to find out that single one element and return that. Now in the last video we learn about the count the frequency, so we can use here. For that, let frequency object, and I'm not using any fancy data structure, any fancy like hash map, hash set, anything, just a normal object, JavaScript object. Start with the for let I equal to 0, I is smaller than nums dot length I plus plus, and let extract the value from nums of I, and here start with the if frequency object has that value, then increase the frequency here. But with frequency, okay, frequency value increment by 1. Else we have to initialize this frequency value with the 1. And in last after that means I created a frequency array, means we count the how many times any element appears in an array. Now let's check which element comes one time. Let I equal to 0, I is smaller than nums dot length I plus plus, and if this frequency of value, not value, nums of I equal to 1, then return this nums of I. That's it, just these lines of code. Let's run this. What happened? Viewers, I think I'm logged out. Wait a second, let's run again. Yes, it accepted. Let's try to submit the solution. Yes, it accepted. That means all the 61 test cases are passed. And but this solution is the brute force, means we are storing the extra, using the extra space here by using this object. But here in this problem statement, this you must implement a solution with the linear runtime complexity. Yes, linear, big open as time complexity, and use only constant extra space. I'm using a object as an extra space, but let's optimize this solution. First I have to comment this, so you maybe understand, means first we track the means make a object and track the frequency of every element, and here we check which element has the value has the frequency 1 and return that nums of I. Now let's try to optimize it. Let result equal to 0. And in the optimization we use the XOR operator. You maybe see the hint. Think about the XOR operator property. XOR means XOR has a property that says if one is the 0, second one is the 0, result is also always 0. And if one is the one element is the 1, second element is the 0, and then it says 1. If 0 is and B is the 1, then it says 1. If both are 1, then it says 0. This XOR operator works on the bitwise on the bit level problem, means bit level solution. So let's try to write here for let I equal to 0, I is smaller than nums dot length I plus plus, and here result equal to result XOR of nums of I, and you have to return the result. So let's submit the solution. Yes, it passed. Let's try to submit the solution. Yes, it accepted. And see, last time our time complexity runtime is the 50% approach, but this may be vary every time, so don't rely on this. Our solution is the correct. XOR is the means we are not using any extra space. In the XOR you maybe think like first, like I have 5 and a 6. First convert them into the bit level number, and then apply the XOR operator. This 0 0 0, 1 0 1, 0 1 1, and 1 1 0. Then you will get the exact number. So here if you see 2 2 1, 2 2 gives the 0, and 0 and 1 give the 1. Here 1 and 4 and means here 4 1 2 1 2, 1 1 gives the 0, 2 2 gives the 0, and 4 0 XOR with the 4. So this is the main idea of this. Now let's come to the second question, second problem statement. This one is the 217 contains duplicate. In this given an integer array nums, okay, return true if any value appears at least twice in the array, and return false if every element is distinct. So here I have an array nums 1 2 3 1, and I have to return true if the element appears at least 2 times. Like here element 1 occur at the 0th index and 3rd index. In the example 2 nums array 1 2 3 4, all elements are single 1 2 3 4, none of the is twice, so we have to return the false. Means if an array has the twice at least twice element, then return the true. Again use the same frequency, const frequency object, and use for let I equal to 0, I is smaller than nums dot length I plus plus, a simple for loop. Now let's extract the value of nums of I in the value variable. If frequency of value and has some value, means it is already count, else frequency of value comes new, then initialize it with the 0 or 1. Else if it is already initialized with the 1, means this time I have to increase the value, means it is duplicate, then just return true here, means we found the duplicate. Mean if any elements come here in the if part, then it must be has any value initially, then just return true. Else after complete the for loop, we have to return false, means we never get any value that has some at least twice. So let's run this code. It's yes, it is accepted. Let's try to submit. Yes, it is accepted and all the 77 test cases are passed. So today we learn about something very important. Code contains duplicate. We see the normal brute force of code here. You can also use into a different way by using the JavaScript set method, and that gives us the big of n time complexity and big of n space complexity. Again same, but this is the similar a short form. For single number, we optimize it for by using the XOR operator. Means first we see the brute force solution, then we optimize it using the XOR operator, and this gives us the big of n time complexity and big of one space complexity. This is how you grow in the DSA. First solve it by using the brute force. No matter, you can also solve the brute force in the interviews also, no matters. Then optimize it, and then understand the patterns. And once you understand the pattern like XOR here, I understand many problems start looking similar. If you found this helpful, make sure to like the video, subscribe to JDCodebase, and continue your DSA journey with me. In the next video, we will solve many more pattern based problems. Keep coding, keep improving. See you in the next video.